In this video, we're going to be doing the required practical for measuring temperature changes in reactions. This is for the C5 topic, lesson 4. So in your book on page 17, you should have a page that looks like this with the list of the equipment, the hazards and risks, and the method that you need to follow in order to complete this practical. I'll just go through the basic equipment with you. We've got a beaker, which is going to be used to hold a polystyrene cup. The polystyrene cup is going to be useful because it is an insulating material, so any heat that is generated through the chemical reaction or by the chemical reaction is not going to escape into the environment. It's going to stay within the solution, and we're going to get a more accurate measurement of what is actually happening during the reaction. So this is placed inside the beaker just because it supports and holds it nicely, stops it falling over. We could actually pack this with some cotton wool to create an even greater insulating layer around it as well, and that would improve the accuracy of this experiment. We also need to place a lid on top, so I've got a plastic lid with some holes in, and this can be used to place a thermometer into, but today we're going to be using this device, which is a temperature sensor connected to a data logger. So I've got a temperature sensor already connected, that's this part here, and this is going to be placed into the solution to measure the temperature, and you'll see the readings come up on the screen. So room temperature is about 21.8 degrees Celsius. We're going to perform a reaction between hydrochloric acid and sodium hydroxide. So following the instructions, we need to add 30 centimeters cubed of hydrochloric acid. So this is hydrochloric acid. We're using a 1 molar concentration, and I'm going to be using the measuring cylinder. This is a 100 centimeter cubed measuring cylinder to measure 30 centimeters cubed. So once we've measured that, we can then pour this straight into the polystyrene cup, place the lid on top, and we can start to take our first measurement. So we can leave the temperature probe in there, and we're starting to get some numbers. We're going to wait until the numbers settle, and then we'll take a recording of this. And what we're going to do is add 5 centimeters cubed of sodium hydroxide solution, and then we're going to measure the temperature again. And when the temperature settles, we're going to add another 5 centimeters cubed, and then we're going to measure the temperature again. So adding 5 centimeters cubed each time and recording the temperature change. Now this information is going to be recorded on the second part of this lesson sheet, which is page 18. So you can see there's a table for you to add some add all of these numbers in. I've done this for you already, and I'll reveal those numbers in just a moment so you can add this to your own records if you didn't manage to do this in lessons. So 5 centimeters cubed measured into the smaller 10 centimeter cubed measuring cylinder. What we can do now is just undo the lid, pour this in, just give it a bit of a swirl, making sure it reacts, and we can now measure the temperature, and you should start to see on the sensor that the temperature is now starting to increase. Just have to keep resetting it every time. So the temperature is increasing. When it looks as if it's remaining constant, which it kind of is now, 22.3 degrees Celsius, I can then have my next 5 centimeters cubed ready to pour in. So I'm going to speed things up. Next 5 centimeters go in, quick swirl, give it a good mix, and the temperature starts to increase again and again. Now we're going to keep adding 5 centimeters cubed until I've reached a total of 40 centimeters cubed in total. And when that's done, you will have all the results you need to complete the rest of the analysis. So here are some mock results that you can use, and I will leave this available here for a moment. So if you'd like to pause the video, then you can right now, and you can use these results for yourself, and your job will be to calculate the mean. There might be an anomalous result in there, so there might be one result that doesn't quite fit, and if that's the case, then it might be sensible to leave that one and not include that in your results, but I'll let you go through those and have a look. So you're going to calculate the mean, and then you're going to use the total volume of sodium hydroxide solution added, and you're going to plot that against the mean result, and that's going to be on the graph paper underneath. And I've given you an example of here how you might lay out the axes. So our independent variable goes across the x-axis, and that was the volume of sodium hydroxide, and we're going to go from 0 to 40, and then the temperature of the reaction is the thing that we were measuring, so that's our dependent variable, and the maximum temperature we needed here was 30 centimeters cubed, so we can do a scale up to 30. So what you're going to notice here is that once you've plotted your crosses, you're going to have a sudden change in the trend. So we haven't made a mistake here at the end. This is on purpose, and if you read the information carefully, it does tell you to draw two straight lines of best fit. So one of the lines of best fit will show an increase, and the second one will show a decrease, and you'll have a point where they cross over, and this is what we're after when drawing the graph. So hopefully that's everything you need to complete this practical, and you should get a graph with two lines that intersect. Okay.